This video is going to fill out the bottom flap of section number 4 of your Unit 7 Similarity Flipbook. We have previously shown in another video that we can prove, if we can prove that two triangles have two interior angles that are congruent, then we can prove that those two triangles are similar, and we can use the rules of proportionality to figure out missing sides. So now we're going to learn two more shortcuts to proving that two triangles are similar. And the first one, or the second one, is we had AA already, angle, angle. Now we've got side, side, side. Now class, you have learned that side, side, side also proves congruence. Well, we can also use it to prove similarity. If the three sides of one triangle are proportional to the three sides of another triangle, then the triangles must be similar. For congruence, we said if three sides of one triangle are congruent to three sides of another, then the triangles are congruent. In this case, if they're proportional, then the triangles are congruent. Now I got to teach you guys a trick, because I remember in high school I had lots of problems with this, and I know many of my students in the past have problems with this because they skip the videos. They don't look at my advice on how to solve these problems. When you get two triangles, class, and you have all of the sides measured, and the question you're being asked is, are these two triangles similar? It is difficult to know sometimes which side matches up with which side, and I'm going to teach you a method to do this. All you do is, on the one triangle, you circle the longest side. On the second triangle, you circle the longest side. The circle matches up the big side to the big side. Oops. Big side to the big side. Now we're going to go ahead and look for the smallest side. On the smallest side, I'm going to put a square around it. And now I'm going to look at the second triangle and put a square around the smallest side. So a square matches up small to small. Small to small. And then you really don't have to label the medium side or the middle side, but if you want to do that, I put a triangle around the middle length. And on this one, the middle length is 4. I put a triangle around that. So you can use a triangle to match up. I'll just abbreviate this one. Big, small, and let's just say middle, middle to middle. When you use these shapes to match up the largest side, smallest side, and the middle side, it makes writing your proportions so much easier. Let's find out whether these two triangles are similar. All you need to do is figure out the scale factor of the sides that correspond. So let's go ahead and match up 15 and 5. Now, you don't know which of these triangles is the pre-image and which is the image. Doesn't matter, as long as you always do it in the same order. So I'm going to put the 15. Let's do that in red so it matches up with our color for our larger side. So 15 over 5. And that ends up being 3 to 1, a ratio or a scale factor of 3 to 1. Let's go ahead and check our smaller side now. Now remember, you put 15 on top of the first one. That came from the bigger triangle. You got to use the same order or same numerator from the big triangle on top of the next one. So 9 is over 3, and that reduces to 3 over 1. So far, so good. And now let's compare the medium to the medium. Again, class, if we used 15 for the first one, we got to use that same triangle for the numerator of our ratio. And we're going to put 12 over 4, and that reduces to 3 over 1. So in this case, we have all three sides of one triangle proportional to the three sides of the other. So I can make a conclusion then. So the triangles are similar. So that's how you match up sides. Let's go ahead and do another example. In this case, I'm getting asked the question, is triangle MNP similar to triangle QRS? Now we have vertices labeled. All right, let's use our same rule. Try to use the same colors here. I use red, green, and orange, so red. Find the largest side of one triangle, circle it. Find the largest side of the other triangle, circle it. Let's assume that MNP is our image, our image, and QRS is our pre-image. So we're going to put the image value on top, so 7.5. Doesn't matter actually. 7.5 over 5. We're going to go ahead and divide that out. In class, that actually comes out to a fraction. Can't simplify very easily a decimal, so I'm going to go ahead and just write that as a decimal answer. There's our ratio. You could also write it as 1.5 over 1. That's fine. All right, let's go ahead and use the square. Here is our smallest side. Now be careful. It doesn't always match up in the same place. In this case, it actually does, but be careful. Notice here, these triangles were definitely reflected. Okay, so let's take a look at, this is the smallest side here is 3. So again, we started off with 7.5 on top from MNP. We got to keep MNP on top. So we've got 4.5 over 3, and that's going to reduce to 1.5. So far, so good. We've got proportionality. Let's do our last one. That's going to be the middle side, which is triangle to triangle. Again, pick the first side, pick the side from MNP. It's got to always be on top in this case. 6 over 4 is equal to, again, 1.5. Class, we have proven that all three sides are proportional. So, our conclusion is this. Since corresponding, actually we should use the word all. Since all corresponding sides are proportional. Notice we have to check any angles in this case. If all three sides are proportional based on the side theorem, then triangle MNP is similar to triangle QRS. So, all sides are proportional. We know the two triangles are similar, and that means the interior angles, corresponding interior angles, must also be congruent. So there is a couple examples of how to use side, side, side to prove similarity. In the next video, we'll do the right side of this page, side, angle, side similarity.